Hi there. In this video we're going to look at this question. Here we have two resistors. Don't forget the rectangle here represents a resistor. We have two resistors and they are connected in parallel. If you want to find out they are connected in series or parallel, just start from the battery and then at this point we can go to the right or down. So we have two different branches. That means that they are connected in a parallel. We have a voltmeter and pay attention, voltmeter is connected in parallel. So always the voltmeter is connected out of the circuit and the ammeter inside the circuit. So the ammeter is connected in series inside the circuit and voltmeter outside the circuit. So what are we going to do now? It says that calculate the values at each point specified. So we have a battery, so we are looking for the voltage here. We are looking for the current there. Also, we are looking for the current here, there, and the voltages across R1 and 4 ohms. So let's start with A1. I tell you that A1 is 8 amps. And let's have a look at why. Look at here, this ammeter here is showing 8 amps. So that means that the current going back to the battery is 8 amps. And because the current is the flow of electrons and the electrons will never ever disappear. So the number of electrons going back to the battery is equal to the number of electrons leaving the battery. So if 8 amps is going back to the battery, 8 amps coming out of the battery. So A1 also shows 8 amps. And because they are connected in parallel, don't forget the total current. The total current is the current coming out of the battery is equal to the sum of the currents through each branches. And here we have two branches. So I1 and I2. Let me show you the direction of the current. So this is the total current, I total, right? And at this point, we have this branch, and then we also have this one here. This one, the green one, is 3 amps. The total one is 8 amps. So we have 8 amps here. Then the green one here is a 3. So what is left for the red one is a 5. So A3 is a 5 amps. And then we have 5 amps here. A2 is also 5 amps because we are going through the same branch here. So this is also 5 amps. And then 3 plus 5 gives us 8 amps there. Now we are going to work out the voltages V1, V2, and V3. I'm going to start off with V3. First of all, because they are connected in parallel, that means that the voltage stays the same. And one more time, the symbol that we use for voltage in Netherlands is U. Then here they have the same voltages because they are connected in a parallel. I'm going, as I said, to start off with this one. And why? The reason is because here I have the current. I know that the current is 5 amps. I also have the resistance here, 4 amps. So I can use this equation that we have, resistance, voltage, and then the current. So voltage is resistance times the current. So V3 is resistance of 4 times the current 5, which gives us 20 volts. And because they are connected in parallel, V2 is also 20 volts. It's really difficult to write down with the mouse. Sorry for the handwriting. And then what is left is the resistance of R1. So we are looking for R. Put your hand on R, and then this is voltage divided by the current. Voltage is 20 divided by the current passing through. This is 3. So 20 divided by 3 is 6.7 ohm. I rounded it off. So 6.7 ohms